Hello everyone, welcome to 2-4, solving equations with variables on each side. So make sure you write your 2-4 in the top left-hand corner. Make sure you write your name in the top right-hand corner, integrated 1, and your period number, and the date. Make sure you write the title, and here we go. So example 1, solve an equation with a variable on each side. Now, if you watch that Facebook Don't Call Me After Midnight video, then you'll know how to solve this already. So going through this, we have Facebook, fraction blast. There's no fractions, so cancel that out. Distribute. There's no groupings. Cuss it out. Combine like terms. 5 and 7a, can't combine them. Forget it. 4a minus 13, can't combine it. Forget it. Facebook, don't call me. Move the smallest variable. Oh, so just move the smallest variable to the other side. So we have 7a and 4a. Now, I'm going to move the 4a to the other side, so I'm going to subtract by 4a. And so this is called the subtraction property of equality. Subtraction property of equality. Okay, next up. So now I'm going to write out, simplify it. I get 5 is equal to, 5 plus 3a is equal to negative 13. Okay, well now I see I have a 5 and a 3. I can't still, no fractions, no distributions, no combined like terms, there's no variables to move. Add away. So I'm going to add negative 5 to both sides. So I can either add negative 5 to both sides, or I can use the subtraction property of equality again. Property of equality to get rid of everything that's not a right there. So I'd be left with 3a is equal to negative 13, negative 5. That would be negative 18. And so Facebook don't call me after midnight, multiply or divide away. Well, that 3 is multiplying, so I'm going to use the division property of equality. Finally switch colors right there. And I'll be left with a is equal to negative 6. Now, what justification do I have for that? I have the division, spell that right, division property of equality. Doesn't matter what you did, just, explain what you did. Like, what did you do? I divided. Oh, then you probably used the division property of equality. Done. Let's go on. Solve an equation with a fraction bar. All right, so the first thing I tell you is I would get rid of fractions. So just multiply by 4 on both sides using the multiplication property of equality. Because the opposite of divide of a fraction with a denominator of 4, that'd be divide by 4, is times 4. So I'm going to use the multiplication property of equality. All right, going back, if I simplify this, I would get, 20y is equal to, this cancels out, 12y plus 16. Oh no, there's variables on both sides. But I got rid of all the fractions, so I'm done. There's no parentheses. Combine like terms, there's nothing to combine. Move the smallest variable. All right, well, move that 12y to the other side. So the opposite, get out of there, transparency, of plus positive 12y would be subtract by 12y on both sides. So that would be the subtraction property of equality. So let's go back. I would be left with 8y is equal to 16. It's times 2. Oh, 16, not 12, 16. So it's going to be times 2. All right, so I'm going to divide. I'm going to divide by 8 on both sides. Can you guys right now tell me what property of equality that is? In 3, 2, 1. All right, that's going to be the division property of equality. Well, how do we know it's the division? Because we divided by 8, that's it. The end. All right, let's go on. So example 5, before we go deeper into this idea. Write an equation with grouping symbols. Well, what if they want you to write an equation? All right, well, let's just write an equation. They say, hey, they have the same area. So how do we figure out what this is? So the area of this would be 5 times x plus 4. The area of this one would be 1/2. The area of a triangle would be half the base. Half the base times the height. 2x minus 6. Well, so they say, hey, these areas have to be the same. Well, okay, well then I'd say if the areas are the same, I'd have 5x plus 4 is equal to 1/2, 12, and then 2x minus 6, not plus 6, minus 6. All right, if you'd like to try to solve it on your paper, I'm going to give you 5, 4, 3, 2, 1. All right, well, let's just do it. So we're going to use the distributive property. Now, I know there's a fraction, but we can just do half of 12. Half of 12 is 6. And then we still have 2x minus 6 right here. So it gets rid of the fraction. We don't have to do anything. But this right here, we're going to use the distributive property to multiply 5 to the x and 5 to the 4, which would be 20. So now we'd have 6 times 2x, which is 12x, and then times this minus 6, which would be minus 36. And all that is equal to 5x plus 20. Now, do they really want us to continue? Well, yeah, why not? Move the smallest variable. Now, let's rewrite this so that we have room. We'd have 20 is equal to 12x minus 5x would be 7x minus 36. I'm going to add the constant away, and I'm left with 56 is equal to 7x. Oh, I know that's 7 times 8, but we don't know that yet. If we divide by 7 on both sides, we get 8 equals x. Done. And so that's the answer. Now, the interesting test question would be, okay, what are the lengths of all the sides? And then you'd have to plug in 8 into the equation right here, like 8 plus 4. So this side would be 12, not 8. And then they didn't ask for this one, but like if we were going for this would be like 2 times 8, which would be 16 minus 6, 10. The height would be 10 right here. That's just something interesting. That could be a test question. All right, let's go on. Now, how many solutions? Now, this is a continuation from 8th grade, but hey, due to COVID, some people might not have learned it, so let's go back over it. Now, something has one solution. For example, if I have 8 equals x, what value of 8 makes this math sentence true? Well, 8. 8 equals 8. That x would have to equal 8 for this to be true. Now, if we have d equals a number, let's just come up with -4. There's one solution that would make this math sentence true. Only when d is -4. That's it. Now, the next part right here, if we solve this equation and we got something for all real numbers, identity, infinitely many solutions. I don't really like infinitely many solutions because it's not really that. We'll explain that more when we get into inequalities. But for this, all real numbers or an identity equation. This is where you have 4 equals 4. When does 4 equal 4? Now, just like above, when does 8 equals x? When x was 8. Now, when does 4 equal 4? That would be always. So this would be an identity equation when all real numbers would work. Now, if we didn't have those, we'd see like x equals x. When does x equals x? All right, how much money do you have in your pocket? Think about that. X is the amount of money in your pocket. So how much money do you have in your pocket? Does that equal How much money in your pocket? When is that true? Always. Now, another thing that we see a lot is getting down to 0 equals 0 or 1 equals 1. Those are good numbers to get to as well, because we see, oh, those numbers will equal that. Now, you'll see this a lot if I had like the equation would be like 2x plus 1 equals 2x plus 1. Now, if I decide to minus 2x on both sides, I would get 1 equals 1, and then we get into this, hey, it's all real numbers type deal. Now, this last part right here is no solution. That's where if we have, or an empty set, or a null set, that's where if you have an equation that can't be true. So if you have something like 4 equals 5, that can't work. Some other ones that we see x is equal to x plus 1. That can't work. Because if you subtract both on both sides, you get 0 equals 1, and that can't work. That is an example of no solution, not x equals 0, because that could work. So like x can equal 0, that'd be one solution. But if you had 0 equal, like when does 0 equal 1? Now if you're like, hey, it equals 1, then I'd be like, all right, I'm going to give you 0 money, you give me $1, and we'll be good, right? No. Last part. How many solutions does this guy have here? Well, let's solve it. If I multiply by 6 distribute, I would get 6y minus 30. Distributing this, I would get 20 plus 6y. Now, if we move the smallest variable and subtract by 6y on both sides, we would be left with negative 30 is equal to 20. So when does $20 equals negative $30? Never. It's never true. So this would be an example of no solution or an empty set. All right, guys. Sorry this one ran a little late. I'll catch you in class. Bye.